We're going to start off looking at the first question. Which variable is categorical? Number of cigarettes is definitely quantitative, but eye color, blue, green, yellow, well, there's really no such thing as yellow, has to be categorical. So whichever one said eye color is the correct one. On number 2, a stem plot would be used instead of a box plot because of number 1, it reveals the shape of the data. This is true. A box plot's not going to show you if it's unimodal or bimodal. 2 is better for large data sets. Absolutely not true. Stem plots usually are made by hand, so it's going to be painful for really large data sets. So this is false. Displays the actual data. Definitely true. In a stem plot you see each and every value. So the choice that says 1 and 3 is correct. On number 3, it says which is true for the distribution shown at the right. The distribution is definitely skewed right, so you can see that tail there. The mean is probably smaller than the median. Not true, because when you're skewed right, the mean is pulled up. We should summarize with mean and standard deviation. Not true. When it's skewed, we should use median and IQR. This next one's kind of interesting. If we're assuming that the data can be modeled with a normal model, then we know that wherever the mean is, oops, I guess I just do that wrong, that we should be able to encompass most of the data if we go 3 standard deviations in each direction. Meaning from the lowest to the highest should be about 3 standard deviations in each direction for a total of 6. So if I take 100, the highest, subtract the lowest of about 35, I'm going to get 65. That 65 unit span should cover 6 standard deviations, meaning that each one should be about 10.83. The closest answer here to that was 12. The next one, it's looking at a normal model to describe the acidity, and they tell you the z-score is 1.8. A z-score of 1.8 means that that has a standard deviation that is 1.8 standard deviations higher than the average rainwater. So that would be choice C. Looking at the ogive, you can see that it's a cumulative graph, meaning that when you get to the top, 100% of the people were ages 60 or under. Hence, to go get the IQR, we're going to need the upper quartile, which we go by finding the 75 and going down and seeing that that was about 45. The lower quartile, which is the score 25% scored less than, which we see is about 32. When I take the upper quartile minus the lower quartile, I get 13. For which graph they should use to show a trend over time, this has to be a time plot. A time plot is the only graph that's going to show change over time. The next question is a pretty typical SAT question. 30 males had an average of 6, meaning that if I summed up all of the male scores and divided by 30, I would get 6. If I solve for the sum of the males by cross-multiplying, I'm going to see that the males' scores sum to 180. The females, the sum of their scores divided by 20 equals 9. Again, cross-multiplying, the sum of the female scores will be 180. To get the final answer, I take the sum of the male scores plus female scores and divide by the total, which is 50. The next question had to do with Obama being inaugurated and saying that he was in the 11th percentile. When we look at a question like this and look at the graph, we need to find the z-score that 11% scored below. To do this, we're going to do z equals inverse norm of 0.11 and get that that would be 1.22 standard deviations below the mean. Now we can set up to solve for the standard deviation. Negative 1.22 equals R score, or Obama's age, 47, minus the mean over sigma, which came out to be about 6.22. The closest answer there was 6.18. Which of the following summaries are changed by adding a constant? Think about adding a constant as shifting the data. So everything moves to the right or to the left, meaning the mean is going to move to the right because we've added a constant. The median will move. But the standard deviation is the spread. And when you shift the data, you are not changing the standard deviation or any measure of spread. So the first two are correct and the last one is not. When I graded this question, I looked for first thing context. You needed to have that this was the weights of 15-ounce snack size bars. A lot of you didn't have the weights. When you went and you SOX this, the shape of A was roughly symmetric and B was skewed to the right. Outliers, some of you thought that A had a low machine or a low weight, and I took that or didn't take it because it was kind of on the fence. In terms of the center, machine A had a higher median than machine B. I'm using the median because of the skewness in the second distribution, which is B, and the outlier in A. Plus I want to compare with the same measure. And as for spread, it's pretty obvious that the spread of B is much higher. So I would say both distributions of weights are unimodal, whereas B is unimodal and skewed right, and A is roughly symmetric with a potential low weight bag. I would then say that the center of machine A was larger than B, but B had a larger range. If I wanted to decide which machine I would use to have the least likely to produce snack bars that have a consistent weight, I would pick B, simply because it has a larger spread. It's not because of its skewed to the right like some of you said. I can have a distribution that's skewed to the right with a very small range, and I can have one skewed to the right with a very big range. It depends on the data. What's key here is that the spread of B was larger than the spread of A. And the last part said, which would you use to ensure that the weight was closer, or the mean closer to 15 ounces? Well, if you looked at B, the median was about 14.7 or so. But since it's skewed to the right, the mean will be pulled up, bringing it closer to the 15. So the correct choice there was 15. In the next question, we were looking at the diameters of the lids, where the mean was 3.98. And if it's too small, you would have to be lower than 3.95, and the sigma was given as 0.02. So we wanted to know the percentage that were too low. So first we're going to find the z-score, doing r-score minus the mean over the standard deviation. This came out to negative 1.5. Then you needed a probability statement, followed by getting our probability and answering with an iffy statement, something to the extent of that about 6.7% are too small. Notice on this command you're going to have to do normal CDF, and you're going to have to go from negative 99 to a z-score of negative 1.5. On the next one, you wanted to have it so that you had 1% less than 3.95. So again, we're going to do inverse norm of 0.01 and get negative 2.326. We're going to have our score of 3.95 minus the mystery mean over the standard deviation. So they should set the machine to about 4 inches. In the next part of the question, we want to leave the mean at 3.98, but change the standard deviation. In order to have 1% below, we'd still have a z-score of negative 2.326. We would now have r score minus the mean over sigma, which would give us a standard deviation of approximately 0.013 inches. Now, in the last question, they want to know which is preferable, changing the mean or changing the standard deviation. The problem about changing the mean is if you shift it up higher, you're going to have more lids that are too big. However, if you take the spread and then you suddenly decide to make it less spread out, you're going to have less lids that are both too big or too small. On the last question, you had to do an outlier test. So you're doing upper quartile minus lower quartile times 1.5. You add that number to the upper quartile and get 230. You subtract it from the lower and get negative 90. Neither the max or the minimum are outside of that fence range. For part B, saying would it be really low at 31.95, a couple of different answers. Some of you said that this didn't fail the outlier test, so no, it's not that unusual. And some of you said, well, hey, it's within 1 standard deviation of the mean. That was awesome because that means it's not unusual. Now, if you got a probability using normal CDF, that would now be incorrect because the data could not be modeled with a normal model. And you could see right away the mean and the median are different, so it was never even symmetric to begin with. It's definitely a skewed distribution. Okay, some of you said that this score fell within the middle 50%. That was great. Saying it fell within the IQR, not so great because the IQR is a number. You meant the middle 50%. Hope this helped.